Hello, brilliant people. Today we are about to embark on an epic journey across the cosmos, imagining life on planets and moons vastly different from Earth. But first, just a little heads up. Throughout this video, I will be showing some AI generated images of the creatures we're going to be discussing. While they look really cool, some of the images might be a bit disturbing to some viewers. I gave myself nightmares creating some of these, so if you're easily disturbed, you might want to take caution when watching this video. Now, with that out of the way, whether you're a science buff or a sci-fi lover, get ready. This is going to be a wild ride. I truly hope you enjoy watching it as much as I enjoyed making it. Section 1, Life on Earth. Before we leap into these alien worlds, let's first ground ourselves by looking at how life has evolved on Earth. Here, the gravity, atmosphere, and oxygen levels have shaped everything from giant dinosaurs to minuscule microbes. During the Carboniferous period about 300 million years ago, Earth's oxygen levels peaked at around 35%, much higher than today's 21%. This allowed massive insects and arthropods to thrive. Imagine dragonflies with wingspans over 2 feet and millipedes stretching up to 3 meters long. The thick, oxygen-rich atmosphere created creatures that seem almost alien by today's standards. Now, picture how changes in the gravity or atmospheric composition could have led to even more bizarre forms of life than these. Extremophiles on Earth provide another glimpse into life's adaptability. These hardy creatures can survive in environments that would kill most others: boiling hot springs, deep sea vents, and even radioactive waste. Tardigrades, for example, are tiny water-dwelling creatures that can endure extreme temperatures, radiation, and even the vacuum of space. If life on Earth can adapt to extremes like this, then imagine what could evolve on planets with even more extreme conditions. So let's dive into a few of the hypothetical worlds now. And we're going to focus on 5 types of planets here: a super Earth, an Earth-like moon orbiting a gas giant, a planet half the size of Earth, a swamp-like planet, and a tundra-like planet. Just to get a nice little bit of variety in here. So for each of these, we're going to explore how life might evolve depending on whether they're orbiting a G-type star like our sun, a red dwarf, or a blue supergiant. Keeping in mind that red dwarfs are, we believe, the most common star in our universe. So first, we have our super Earth, a planet with 2 to 10 times Earth's mass. The higher gravity here would be a game changer for life. If it was orbiting around a G-type star, the super Earth would receive similar light and energy as Earth, but with a twist: the crushing gravity. Life here might resemble the squat, muscular dwarves of fantasy lore, but these beings would be real: 3-foot tall, 3-foot wide powerhouses, with dense bones and muscles designed to withstand the intense gravitational pull. Think of the dwarfs from The Lord of the Rings, but even sturdier and stockier, with short legs and arms evolved for brute strength rather than speed. Plants might also be low to the ground, with thick, fleshy stems designed to conserve energy to resist themselves from being crushed. If it was orbiting around a red dwarf, the super Earth would likely be tidally locked, with one side perpetually facing the star. Life here would have to deal with both the gravity and extreme temperature differences. Picture burrowing creatures with tough, armor-like skin that helps them survive the temperature extremes. On the twilight band between the hot and cold sides, life could evolve eyes that could see in infrared, similar to thermal vision used by Predator in the sci-fi franchise. But these creatures might resemble a mix of armadillos and moles, designed for digging and hiding from predators that hunt in the shadows. Now, if we had a super Earth orbiting a blue supergiant, it would be bathed in intense radiation. Life might evolve natural armor, thick reflective exoskeletons, or scales similar to the kaiju from Pacific Rim. Due to the short lifespan of the star, evolution would happen rapidly, leading to creatures with a wide variety of survival strategies. Some might burrow deep underground, while others could have iridescent, mirrored skin that reflects the harmful rays. Picture a world teeming with life forms that adapt quickly or face extinction, like living, breathing battle tanks. Now, let's explore an Earth-like moon orbiting a gas giant. This moon is half the size of Earth, and its environment is shaped by its parent planet in this scenario. So, if we're orbiting a G-type star, this moon would experience long days and nights due to its orbit around the gas giant. Life might evolve in cycles, with plants blooming rapidly when sunlight is available and hibernating during a long night. You might see amphibious creatures that can move between water and land, like the xenomorph from Alien, but adapted to the fluctuating conditions. These creatures could have bioluminescent features to navigate the dark nights and sleek, adaptable bodies designed for both swimming and running. If this moon orbited a red dwarf, it might be tidally locked to both the star and its gas giant parent, creating complex climate zones. Life here might resemble the Na'vi from Avatar, with sophisticated navigation skills and bioluminescent skin to communicate and find food. These creatures might migrate between hot and cold zones, following the ideal conditions. Plant life could be as adaptive as the Triffids from the day of the Triffids, able to uproot and move to more favorable areas when needed, perhaps even with carnivorous tendencies to supplement nutrients in harsh conditions. Now, if it were orbiting a blue supergiant, it would face extreme radiation and erratic energy bursts. So imagine a nomadic species that resembles sandworms from Dune, constantly on the move to avoid dangerous radiation spikes. These creatures might have reflective shells as well, nocturnal habitats, and even the ability to hibernate for long periods. Lower gravity will lead to taller, lankier creatures designed for rapid movement across the moon's surface. Think of something like the engineers from Prometheus: tall, elegant, yet eerily powerful beings. Now, let's just consider a smaller planet about half the size of Earth with much lower gravity. Now, if it was orbiting a G type star, it might have a thinner atmosphere, making it challenging to retain warmth. Life here would resemble the flying creatures from Avatar with large wingspans and lightweight bodies designed for gliding over long distances. Plants might grow tall and thin, but with spindly branches that stretch toward the sky, kind of like the sequoias of Earth. Picture delicate spider like creatures that can move quickly across the vast expanses, using webs or gliding to cover ground efficiently. Now, if our smaller planet was orbiting a red dwarf, life might evolve in the narrow habitable zone where temperatures are just right, just kind of like our super Earth. But the low gravity could lead to floating or balloon like creatures, similar to the aliens from Arrival. These beings might drift along the twilight zone, using subtle air currents to navigate between light and dark. Plants could be flat and wide, spreading horizontally to maximize sunlight absorption, like the flora on the Pandora and Avatar. And if our small planet was orbiting around a blue supergiant, life would need to cope with low gravity and intense radiation. So picture tall, willowy creatures that resemble the Slender Man mythos, long, spindly limbs designed for quick, graceful movement. These beings might have reflective or translucent skins to scatter harmful rays, and they could burrow underground to escape the searing radiation. Low gravity could also give rise to the balloon like organisms that float just above the ground, similar to the Medusae from Hyperion by Dan Simmons. Now, let's imagine a swamp like planet with vast wetlands, murky waters, and dense, humid air. If we had aliens on a swamp planet around a G-type star, life might evolve to thrive in waterlogged environments. Picture creatures similar to the Swamp Thing from DC Comics, with plant-like appendages that allow them to blend into their surroundings. These beings could have symbiotic relationship with the swamp's flora, perhaps even sharing nutrients or communicating through the root networks, like the Ents in The Lord of the Rings. Amphibious predators might lurk beneath the water's surface, waiting to ambush prey with lightning-fast reflexes. Now, if the swamp planet orbits a red dwarf, the ecosystem might be bathed in perpetual twilight, with bioluminescent plants and animals lighting up the landscape, like the forest of Pandora and Avatar. Predators might develop infrared vision to hunt in the dim light, while prey species could evolve complex camouflage abilities, similar to the predator's cloaking technology. Picture an environment teeming with life forms that are both beautiful and deadly, where the line between plant and animal blurs in fascinating ways. Now, if our swamp planet was orbiting a blue supergiant, it would face extreme radiation and erratic energy bursts, leading to life forms with extraordinary adaptability. Imagine creatures with thick, armored hides, similar to the Rancor from Star Wars, able to withstand both the swamp's humidity and the radiation from their sun. Plants might evolve to close their leaves or retract into the ground during radiation storms, much like a Venus flytrap snapping shut, but on a much larger scale. In this environment, the creatures could possess regenerative abilities, healing quickly from the frequent environmental damage, reminiscent of the mutant lizards from the Cloverfield paradox. And lastly, let's explore a tundra-like planet, covered in icy plains, frozen lakes, and harsh, biting winds. On a tundra planet that's orbiting a G-type star, life would need to adapt to freezing temperatures and limited food sources. Picture creatures similar to the Tauntauns from Star Wars, with thick fur, insulated layers of fat, and the ability to generate body heat to survive the cold. These beings could have antifreeze like blood, much like some Earth fish, allowing them to endure sub zero temperatures. Predators may develop stealth hunting techniques, blending into the snowy landscape like the Wampa from The Empire Strikes Back, waiting to ambush unsuspecting prey. Now, if this tundra planet were to orbit a red dwarf, the weak sunlight would create a world locked in perpetual twilight, with temperatures even colder than Earth. Life here might evolve to live underground, like the graboids from Tremors, burrowing deep into the soil where it's warmer. Surface creatures could be covered in reflective scales or fur to capture and retain heat, with eyes adapted to see in near darkness. You might also find sprawling underground ecosystems where life flourishes despite the frozen surface above, similar to the Morlocks from the Time Machine. And on a tundra planet orbiting around a blue supergiant, the cold would be extreme, but so would the energy burst from the star. Life forms here might resemble the frost giants from Thor, with an ice-based biology that thrives in the cold, but can also absorb and store energy from the rare but intense flashes of sunlight. Plants could be hardy, low to the ground, and covered in thick ice, only thawing during brief periods of warmth. The most adapted creatures could have an almost crystalline structure, shimmering in the light, resembling the beings in the abyss. And then finally, section 3 are life in extreme environments. Beyond these terrestrial worlds, let's stretch our imaginations further into the clouds of Venus. Life in the clouds of Venus. Venus is often seen as a hellish planet, with surface temperatures hot enough to melt lead and crushing atmospheric pressure. However, 50 kilometers above the surface, conditions are more Earth-like, with cooler temperatures and atmospheric pressure similar to the sea level here on Earth. In these clouds, life might take on forms similar to the jellyfish-like creatures from the sky crawlers, large floating organisms that drift through the thick sulfuric acid-laden atmosphere. These beings could have evolved to extract nutrients from the clouds, using photosynthesis-like process or even feeding on the microscopic life forms that might exist in the dense atmosphere. Their bodies could be composed of lightweight, flexible materials that withstand the corrosive environment, while allowing them to remain buoyant in the clouds, like living airships. The cosmos is vast, mysterious, and it's full of unimaginable possibilities. So, whether we're talking about a super Earth with muscle bound creatures, an Earth like moon with amphibious hunters, or a swamp planet teeming with bioluminescent predators, each world offers a unique stage for life to evolve in bizarre and fascinating ways. By drawing comparisons to the creatures we know from our favorite sci fi films, we can stretch our imaginations even further and appreciate the endless diversity that the universe might hold. So, what do you think? Could we one day discover a world like these? Or perhaps in some distant corner of the universe? Are there creatures looking up the sky, wondering if they're alone, just like us? If you enjoyed this journey through the cosmos, please be sure to like, comment, share, and subscribe, and don't forget to check out the linked content for more deep dives into the mysteries of space. I hope everybody learned something and most importantly had a lot of fun today, and thanks a lot for watching. Have a great day.